Example 4, boll weevils are a threat to the cotton crop. A farmer owns a small farm and can protect his crop by spraying with a potent, expensive insecticide. He can save money by not spraying, but he risks losing his crop to the boll weevils. A farmer set up a payoff matrix as shown, where the numbers in the matrix represent his profits in thousands of dollars. What should the farmer's strategy be? What are his expected profits, assuming the boll weevils know how to use their optimal strategy? Okay, so we want to know what the farmer should do and what the value of the game is, basically. First thing you want to do is look for a saddle point. If there's a saddle point, it's easy. That's last lesson. That's 11.5. So remember, you underline the lowest number in each row, and then you circle the highest number in each column. And if you underlined and circled something, that was the saddle point. It was strictly determined. But since I don't, this is not strictly determined. That's why it's in 11.2 and not 11.1. The farmer's best strategy is not to do the same thing every time, but to mix it up. It's not strictly determined. So, what should the farmer do? What we're going to do is say his strategy looks like this. Notice there are only two strategies, either to spray or not to spray. And we're going to take this row vector for the farmer, let the farmer be the row player, and we're going to multiply that times the payoff matrix. So remember how we do that. How we multiply is we take a row times a column. So remember, 1 by 2 times a 2 by 2 is going to be a 1 by 2. So make sure your answer is in the form of a 1 by 2. So the first row times first column, zip up your numbers, take the first numbers, that's p times 6 is 6p plus, and then you'll have 1 minus p times negative 8, so negative 8 times 1 minus p. That's the first column. Now we're going to do the same thing, but this time we're going to do this row times this column. Okay? So, zip up your numbers again. We're going to have p times 4 is 4p. And then multiply the second numbers, 1 minus p times 10. So plus 10 times 1 minus p. And there's our matrix. There are our two expressions. Okay? Make sure you write small. Don't have a whole lot of room. But what we want to do here is set those two expressions equal to each other. And I'm going to have 6p minus 8 plus 8p equals 4p plus 10 minus 10p. So set those two expressions equal to each other and solve. I'm going to have clean up on the left, 14p minus 8. And on the right, that's negative 6p plus 10. Okay, all I'm trying to do is solve. So this is just straight algebra. Add the 6p over, that's 20p. Add the 8 over, that's 18. 20p equals 18. So p equals 18 over 20. But that reduces to 9/10. Okay? P equals 9/10, and that's this number right here, right? Okay, so the farmer's strategy, the farmer's optimal strategy should be 9/10 for the first row, or spray, and 1/10 for the second row. Don't spray. He should spray with a probability of 9/10, or he should spray 9 times out of 10. Okay? So that's the farmer's strategy. What should the farmer's strategy be? There you go. Spray with 9/10 probability and don't spray with 1/10 probability. What are his expected profits? Well, that's where we find the value. So remember, for the value, we're going to multiply the farmer times the payoff times the boll weevil. So we can't do the value of the game without doing the boll weevil strategy. So we're going to have to do kind of the same thing for the boll weevil. Remember, this is backwards. You have to do it in this order. Otherwise, the matrix multiplication doesn't work out. Remember, we've got a 2 by 2 times a 2 by 1. That's the only way this is going to work. And we're going to be left with a 2 by 2. So zip up.
2 by 1.
2 by 1. Thank you. Thank you. You're right. So row times column. It's going to be 6p plus 4 times 1 minus p. Barely fit it in there. Okay. Now we do the second row times that column. Negative 8p plus 10. There's no way I've got enough room. Times 1 minus p. All right, but we've got those two expressions. We set those two expressions equal to each other. So 6p plus 4 minus 4p, that's the one on the top, equals negative 8p, distribute the 10, so plus 10 minus 10p on the bottom there. So we set those two expressions equal to each other and just solve. On the left side, 6p minus 4p, I've got 2p plus 4. And on the right side, that's negative 18p plus 10. Okay. I would add this 18p over and get 20p. Subtract the 4 over and get 6. So we can see that p equals 6 over 20, which reduces to 3/10. So the boll weevil's strategy would be 3/10 and 7/10. Or 3/10 attack, 7/10 don't attack. Attack 3 out of 10 times, don't attack 7 out of 10 times. That would be the boll weevil's strategy. Now we need to find the value of the game. So value of the game, we multiply our three matrices, and it has to be multiplied in the right order. Okay? So value (9/10) and 1/10 times the payoff was 6, 4, negative 8, 10, 3/10, 7/10. Now, of course, you should be able to do this by hand, but let's shortcut this and do it on calculator, especially since we're running low on space. Okay, I like this. I like this one at Desmos. Okay, I'll clear all. New matrix. Is a, what is it? One row. Okay, so what do we have here? 9/10 and 1/10. New matrix B is a 2 by 2. It's already there. 6, 4, negative 8, 10. And C is a 2 row, 1 column, 3/10, 7/10. That, and I need to multiply them. And notice I get 4.6. Okay, so that's the value of this game. That's the value. All right, so make sure you answer the question. The question was, what's the farmer's strategy? Farmer's strategy is spray 9/10 of the time and don't spray 1/10 of the time. And then we also had to figure out his profits. Okay. Remember that this payoff was done in thousands of dollars, right? So when we got this value of the game, that's in thousands of dollars. All right. So his profit is $4,600, or why don't we just say $4,600.